basic internal structure of an index in Lucene. Here you can see the basic internal structure of an index. This figure shows the basic internal structure of an index. The data in a segment is represented abstractly rather than as a realistic representation of actual data structure. Index. This is similar conceptually to database table, but differ in some important ways. The table in traditional relational database or NoSQL database needs to at least have its scheme defined when it is created. There are some clear constraints on the definition of the primary key, columns, and the like. However, there are no such constraint in Lucene index. Lucene index can be understood as a document folder. You can put a new document into the folder, or you can take one out. But if you want to modify one of the document, you must first take it out, modify it, and then put it back in the folder. You can put all sort of document in the folder, and Lucene can index the document whatever the content. Document similar to a row in a relational database. So a document in a document database, an index can contain multiple documents. A document written into an index is assigned a unique ID. That is the sequence number, more usually called doc ID. Sequence numbers are doc ID. Field. One document is made up of one or more fields. A field is the smallest definable unit in data index in Lucene. Lucene provides many different types of field, including string field, text field, and numeric data values field. Lucene determines the type of indexing, such as inverted index, stored field, doc values, or n-dimensional, to use for the data depending on the field type, the type of the field type. Field and field type field type. The term and term dictionary, smallest unit of index and the search in Lucene. Field consists of one or more terms. The term is produced when a field is put through an analyzer, tokenizer. The term dictionary is the basic index used to perform conditional searches on terms. Segment. An index is composed of one or more sub-indexes. A sub-index is called segment. The conceptual design of segment in Lucene is similar to LSM, but there are some differences. They inherit the data writing advantage of LSM, but only provide near real-time but not real-time queries. When Lucene writes the data in first write to a in-memory buffer similar to memtable in LSM but not readable. When the data in the buffer reaches a certain amount, it will be flushed to become a segment. Every segment has its own independent index and are independently searchable, but the data can never be changed. This scheme prevents from random writes. Data is written as batch or as an append or achieves a high throughput. The documents written in segment cannot be modified, but they can be deleted. The deletion method does not change the file in its original internal location, but the doc ID of the document to be deleted is saved by the another file to ensure that the data file cannot be modified. Index queries need to query multiple segments and merge the result, as well as handling deleted document. In order to optimize queries, Lucene has a policy to merge multiple segments, and in this regard is similar to LSM's merge of SS table. Before segments are flushed or committed, data is stored in a memory and is unsearchable. There is another reason why Lucene is said to provide near real-time and not real-time queries. After reading the code, the reason for this is the searching of data in Lucene relies on the index setup. For example, the inverted index relies on term dictionary, and the data index in Lucene is set up during segment flush and not in the real time. The purpose of this is to set up the most efficient index. Naturally, it can introduce another index mechanism that set up the index in real time as it is written, but implementation of such mechanism would differ from the current index in the segment, needing the introduction of extra index at the right time, and an extra query mechanism involving some degree of complexity. Sequence number is called doc ID. Doc ID is an important concept of Lucene. The database uniquely identifies a row using primary key, while Lucene index uniquely identifies the doc by its doc ID. However, the following points should be kept in mind. One, the doc ID is not actually unique to index, but is unique to a segment. Lucene does this mainly to optimize the writing and compression. Since it is only unique to a segment, how can a doc be uniquely identified at the index level? The solution is simple. The segments are ordered. To take simple example, an index has two segments, and each segment has 100 docs. Respectively, the doc IDs in segment are 0 to 100, but when they are converted to the index level, the range of doc IDs in the second segment is converted to 100 to 200. Doc ID is unique within a segment, numbered progressively from 0, but this does not mean the doc IDs are continuous. When a doc is deleted, there is a gap. 3. The doc ID corresponding to a document can change, usually when segments are merged. The inverted index, a very core of Lucene, is essentially list mapping each term to the doc IDs of the document containing the term. So when Lucene is searching internally, it makes a two-phase query. First phase is to list the doc IDs found to contain the given term. So when the Lucene is and the second phase is to find the doc based on the doc ID. Lucene provides functionality to search by term as well as to query on the basis of doc ID. Doc ID is basically an int32 value starting from 0, which is an important optimization. Also reflected in the compression and query efficiently. This includes such optimization as a delta policy for data compression, zigzag code, skip list used in inverted index list. These are here you can see doc in-memory buffer segments, and segments are in index. Doc is connected to in-memory buffer via add document, and in-memory buffer is connected to segments via flush. Here as an example, here segment 0, 1 and 2 is content to segment for via merge. Here the in a segment you can see doc IDs and doc, and here the as an example here the doc ID 4, the doc 4 is connected to here doc 4 here. It has fields and values. Now this is the end of my presentation. Thank you very much for watching it.